Hey guys, we are starting a unit called the Fundamental Theorem of Algebra. You can find these blank notes and the entire note packet in our Google Classroom site. If you don't want to print it, don't have access to print it, that's totally fine. Grab a piece of scratch paper, grab a notebook, and just kind of jot some of these ideas down so that as you're working through your practice, you can do this. But the big thing is we are solving polynomials with graphing. And what I want you thinking about is how does the graph shape impact the solutions, or specifically the number of solutions? So one way to find roots is to graph. And we, of course, are going to do our favorite and use Desmos to graph, right? We are going to do a lot of graphing in Desmos this unit. So I know it's on your Chromebooks. If that is an issue, let me know. But I'm really hoping we can make Desmos do most of the thinking for us. There are a couple keys to reading these graphs, and so I'm going to show you 3 examples quick, and we can kind of look at what each graph or what a graph could potentially look like and how that impacts the solutions. So I'm going to sketch 3 graphs. Very, very high-tech sketches we got going on here. And we are going to kind of just look at each possibility that we might see. The first is I'm just going to draw a super basic graph, and what could it look like? It could look like this. There we go. Super exciting graph. Lots going on. However, it really only has one solution. It only crosses the x-axis this one time. And I'm going to say it crosses at about -5. Even though it makes a ton of turns, what's happening is it's crossing, right? Different idea. It's crossing at -5, and it's passing through, hitting the axis and continuing on at -5. So my answer is x equals -5. Now I'm going to switch that up here in my next one. I'm going to draw a parabola, right? Parabola is a type of polynomial, or a quadratic is. And I've got one solution right there at the top of the parabola. And we're going to say that's at about, I'm going to say x equals 2. But what's different here is the graph didn't just pass through at x equals 2. Instead, we have what's called a multiplicity of 2. Because what happens is the graph bounced off and went back the other way. And what that means is it doesn't pass through. It's kind of like a pinball in a pinball machine where it hits and comes off. And that hitting and coming off changes how many times x equals 2 is a solution. Another way we can change is we can do kind of a wiggle. So I'm going to come up with my graph. I'm going to get closer and closer to the x-axis. And then as I get closer, I'm going to flatten out. And then I'm going to turn. And then I'm going to get steep again. But at that flattening out spot, because my graph got flatter and had sort of a wiggle, now the multiplicity is changed to 3, which means x equals -2 is a solution 3 times. Okay, so let's add some kind of clarifying notes on here, and hopefully you can get them written down on your paper too, or whatever you're using for writing. If we just pass through, we have a solution 1 time. If we kind of do that pinball bounce, that's when we get our multiplicity of 2. And if we have that wiggle, almost like someone's trying to shake a defender, right? They're coming up, they slow down, and then they change speeds. That wiggle gives us multiplicity 3. Okay, and that's maybe an important note. When I say mult, I am abbreviating for the word multiplicity, which means this solution shows up this many times. So mult 2 means x equals 2 is a solution 2 times. So I think it'll be helpful for us to look at an example, right? Got a beautiful graph here. It's got a lot going on. It's got a lot of turns. It's got some things we can recognize. First thing I want to remind you of is this right here is the x-axis. So we are looking along this line right here. Okay? And we are looking for places where the graph either crosses that line, bounces at that line, or wiggles at that line. And so I can immediately see 3 places where it's going to do that. So let's talk about each place individually. So the first place is right there. Second place is here, and here's the third place. So I'm kind of marking those up on that graph. And now we're going to write about them. So the first solution I see is x equals -2. And that only has multiplicity 1 because we just passed straight through the graph at that point. The next spot I see is x equals -1. But at x equals -1, we have a wiggle, right? The shape of the graph is that it kind of comes up, flattens out, and then turns and changes speeds and goes up again. And that wiggle says we have multiplicity 3. What that means for us, x equals -1 is a solution 3 times. Okay, that feels weird. It feels weird to have to say that -1 happens extra times, but it does. And so I want to make sure we list them all to account for what we see on the graph. Keeping that idea of what we see in the graph in mind, the final solution I see is at x equals 1. Okay, and so at that x equals 1 spot, we bounce off, right? That idea of the bounce means that we have it as a solution 2 times. And so I want to make sure we list it both times. And so the final answers here are -2, -1, -1, -1, 1, 1. Okay, so we can list all of them to account for those multiplicities in our graph, right? And so be very, very careful of depending on how the graph is turning, that's what we need. We've got 2 kind of examples down here that I am going to jump to Desmos to show you. So what I would love for you to do right now is to also jump to Desmos. So I don't know if you want to make your window split screen. I don't know if you want to just listen to me talk and you graph it on Desmos. I'll try and explain everything I'm doing. But we are going to graph this first equation, x to the 4th plus 2x to the 3rd minus 4x to the 2nd minus 8x in Desmos. So here we go. Okay, so here we go, Desmos. We got 2 graphs here. I'm going to turn off the second one to kind of kick things off. But I want to look at this first one and kind of see, I think I have a typo. Yep, I am missing a 4 on that X right there. So I'm going to sneak one of those in quick because that's going to change my graph and I want to make sure we're looking at the right graph. So thank you for hanging tight with me for a second. Okay, so now I'm looking at this graph. And in this graph, I see that we cross 3 times. I've got a solution at -2. I've got a solution at 0, and I've got a solution at +2. The solutions at 0 and at +2 both have multiplicity 1 because the graph is just passing straight through, but at -2, we do a bounce. And so I want to make sure I account for that 2 times. Okay, so that's the answer for our first graph. To look at the second graph, I am going to kind of wipe out where we started with from our original, and let's go to maybe green. And it looks like we've got a solution here where we're passing straight through. We've got a solution at 0 where I'm passing straight through. And I've got a solution kind of right in here that it's a little bit harder to read, but if I tap it, Desmos loves to take good care of us, and it's going to tell me and disappear that x equals 0.5. Okay, so if you want to see that again, I'm just going to tap it. And hopefully you're clicking on your screen right now as we're going through this, but there's my third solution. Notice in all 3 cases, we did just straight passing through, which is why I didn't duplicate any of them. So in those 2 examples that we were just looking at, we want to get those typed in Desmos and read what's happening in the graph. So as you are working through this, lots to keep in mind, but the most important thing is where do we cross the x axis and how do we cross the x-axis? So go back, double check this, check it out, try those 2 in Desmos, and keep me posted if something sounds funny. Thanks, guys.